Hello everyone and welcome back to our Copilot Studio series on modern financial intelligence. Last video we focused on structured finance data, building a governance solution in Microsoft Fabric. This video we shift to the other side of the equation, which is institutional knowledge, things like finance policies, process documents, reference notes and guidance material. This information doesn't change every now and then, but it does change and it is maintained in SharePoint by business SMEs. That's what we are going to focus on today, building an ingestion pipeline that keeps this institutional knowledge fresh, AI ready, and governed. RAG or retrieval augmented generation is as good as the consistency of the updates or the quality of the indexing. If the ingestion is not automated, policies go stale, AI answers drift, and trust breaks down quickly. So before we connect anything to our AI agent, let's get the ingestion and retrieval right. So let's get started. Before we start the build, let's look at the design. We already have Fabric in place. For RAG, we'll start where most finance knowledge already lives, SharePoint. SharePoint is where teams collaborate, review, and publish documents, and it should remain the system of collaboration. From there, blob storage becomes the neutral landing zone, and Azure AI Search becomes the retrieval layer for RAG. Each component has a clear responsibility. SharePoint for collaboration, Blob for decoupled storage, and Azure AI Search for chunking and retrieval. Towards the end, we'll integrate a REST API to fetch live exchange rates. For this series, we will use logic apps for simpler auditable ingestion flow. Alternatively, this file synchronization could be implemented using Azure Data Factory, which supports bidirectional sync between SharePoint and Blob Storage. So let's move on to Azure Portal. So before we move on to the Azure portal, let's have a quick glance at the SharePoint folder. So this is the folder which we will use to synchronize the files between the SharePoint folder and the Azure blob. We'll open portal.azure.com, search for Logic Apps and create a new Logic app. I have in my recent Logic Apps. Let me go and select that one. Click on Create. I'll select multi-tenant consumption because both SharePoint and Azure Blob are first-party Microsoft connectors. Additionally, this is going to be a triggered sync, which is low cost and fast setup. Also, the pricing is going to be as pay per run. So let's go ahead and select. You need to select the resource group where you want this Azure resource to be in. Let's give it a name, cash flow SharePoint to blob sync. And all my development resources are housed in East US. So I will go ahead and select East US. And let me go ahead and click on review and create. Once I click on create, I can see that the deployment is went in progress and now it's complete. I'll go to the resource and I will try to edit the flow so that I can have all the configurations in place and steps in place which does the sync. Let me click on the placeholder add a trigger. Now it's going to be a SharePoint trigger. So I need to search for something which says that when a file is created or modified like this one. So once I see the screen, I need to click on sign in and enter the account credentials via where my SharePoint files are hosted. So let me go ahead and click on sign in. We can also specify the folder which needs to be checked. Then we can set the intervals we want to check items in the SharePoint folder. I will set this to hourly once, or you can even set it to once a day depending on your requirement. Then you can select the time zone and close the side panel. Let's now add an action to get the files. So let's go to the SharePoint connector and search for get file properties only. And And we need to mention the site address over here, the library name, and we can limit our entries to the particular folder where our documents reside. Once done, we can close the pane and now we add a new action which says get file content. So let's go again to the SharePoint connector and click on see more and search for get file content. So here again we need to select the site address and the file identifier. The file identifier in this case will be the identified dynamic content from our earlier step. So let's go ahead and select that. Let's search for something which says identifier. Okay, here it is. And we see that as soon as we select identifier, a for each loop comes into picture. This is because there might be multiple files that we might be getting from the SharePoint and it has to iterate through each one of them. Once done, we can now close the pane over here. The next thing that we need to do is get the blob, create a blob. And for that, let's move on to our storage container. So this is the storage account that I had created, and let's go ahead and create a container inside it. So let me click on add container and provide it a name. For the demo purposes, I'll use cash flow forecast and click on create. So right now this particular container blob is completely empty. So let's go back to our storage account, and since we need to connect to this particular blob, we need to pick the account name and the access keys to create the connection for it. So let's go to the security and networking blade and click on access keys. So here you can copy your storage account name and the key over here and copy it into your clipboard and save it for our next step. Let's go back to our logic app flow and add an action to create a blob. Let's pull this action. The storage account that we need to access is the one that we saw earlier. I have already connected to this particular storage account, so I'll use the same connection settings. I need to specify the folder path. So let me go ahead and click on this folder icon, which is my cash flow forecast. The blob name is something that I need to pick up from the earlier step. So let me create an expression for it. So I need to pick the items that are there under the for each loop. So let me go to dynamic content and click on current item. Since we have already got all the files using the get file properties only action, we need to iterate through them one by one. So let me put up a question mark here, and the file name with extension is something that I would have got in the get file properties only step itself. So let me search for it. So here it is, file name with extension. I'll go ahead and remove this additional content. And this is my expression for getting the file name populated. Let me click on add and I can see that it has got accepted. If it was not, there would have been an error. And the next thing is the blob content, which is again a dynamic content that I need to pull from the earlier step of get file content. So let me click on the dynamic content and select file content. So it's done now. We can now close this pane and save our flow. Once the flow is saved, now we are ready to run our logic apps. So let's go ahead and click on run. So we can see that the flow has successfully run. Now let's go back to our blob and see if we can spot the files that were there in our SharePoint. So we can see all the files that have been created and they are present in the particular container that we had selected. Now let's make this content usable by AI. Let's go back to our Azure portal homepage and search for Azure Search Index. And we can see the AI search option has popped up, and let's click on create. The subscription and resource group has already loaded up. I can key in the name for the service, and let me go ahead and say Azure cash flow RAG, sorry. And the location, we can select anything, but for my purposes, I have mentioned earlier that I would like to go ahead and use East US for all my development work. Click review and create and hit create. So Azure AI Search is what enables RAG to work reliably at scale. We'll create a data source pointing to the blob container, define an index over here, and configure our vector field for embeddings and a skill set for text extraction and chunking. So the deployment is complete. Let's go to our resource and let's start importing the data from our blob. So we'll be targeting a RAG based scenario. So let's select RAG. The storage account will be the one that we saw earlier, and the blob container will be the one that we created, cash flow focus. Now let's click on next. So for vectorizing our text, which is the next step, we would have to go to Microsoft Foundry and select a project from there. I have already gone ahead and created a FinServ dev project, which is there in my development environment and the East US region. What I need to do is now go ahead and deploy a model over there. So let me switch to the Microsoft Foundry homepage, and here I can see that I have already created a project and all the project details are present over here. The step that I need to take over here right now is to deploy a model. So let me go ahead and find the appropriate model for my use case. Since my use case is all about policy documents, I will try to pick a text embedding model. Let me pick this and click deploy. So here is my text embedding model deployed. Let me go back to my Azure portal and refresh this. And I can see the model over here. And let me check the pricing acknowledgement. Now, since I do not have any images over here, I can skip this for now. And I can schedule my indexing if my policy documents keep changing every now and then. I can set up a custom scheduler as well. For my use case, currently, let me leave it at once. I'll click on next and hit create over here. I can create a RAG name for it. I can put in a custom RAG name. So let me go ahead and use cash flow RAG so that it reflects. So the indexer, data source, skill set, everything has been created. Let me go back to my search explorer. Let's go and examine the fields. So here we have chunk ID, parent ID, chunk title and text vector. What is missing is the URL or a clickable citation source. So let's add that by clicking on add field and mention the name as URL. We want it to be of type string and it should be retrievable, filterable, sortable, face table and searchable. So let's click on save. And hit save again. Now let's have a quick look at the JSON. We can see all the fields over here And then we have the default semantic configurations with prioritized fields as title and chunk. Chunk is basically your content which has been chunked. And then we have the vectorizers that we mentioned during the wizard that we used for creating the index, indexer, and skill set. Now let's hit cancel. Everything looks good. And we can go back to our indexer. Now let's go to indexer. Let's click the indexer that we created and click on edit JSON. So over here we can see that the field mappings has a metadata storage name, but it doesn't have a metadata storage path. Basically the URL field that we created in the index. So let's go ahead and create that. And we can modify this to reflect path, and our target field name is URL, and we don't have a mapping function, so we can skip that and click on save. So once done, we can run our indexer and ensure that it runs with success and it has no errors and all the fields are mapped correctly. And we can see that it has succeeded. Now let's quickly grab the search endpoint and the key for authentication purposes. So we'll go to overview and get the URL from here, and we can keep it safely in our notepad and go to settings, then click on keys and use the primary admin key and again copy to clipboard for using it via our Visual Studio Code. We'll add one more small capability. Moving on to external API integration, we'll open a browser tab and navigate to this particular portal and retrieve an API key. This gives us a third data source, which is real time external data that the agent can query on demand. You can key your email address and get the free key in your inbox. Back in our VS Code project from the last video, we'll create three more files. One is for our RAG, the other would be for the external API access, and the third one would be the main file which has the MCP configurations. So before we go ahead and add the code into the files, let's update our .env and the config file with the details that we got from our search and the from our search and the external API browser window that we open. So these are the values that we picked up: the Azure AI Search endpoint and key, the base URL of the external API integration, and the API key which you might have got in your inbox. And we set up a base currency of GBP. You can mention your interest of currency, and these are the local MCP server configurations that we have mentioned as a best practice. Let's go ahead and update our config file as well. Now moving on to the external API.py file, let's add the API integration. So all configuration is loaded from the environment variables via config.py. Exchange API key is basically for API authentication. FX base currency is the default base currency, and FX API base URL is the API endpoint. If no base currency is supplied, the default is used, and this supports both standardized queries and ad hoc agent requests. The function fails fast if the API key is missing. The API is called at runtime, and a timeout is enforced to prevent hanging requests, and responses are logged for traceability. Any upstream API failure is detected, logged, and surfaced explicitly, and only the required rate is returned, not the full payload. This keeps downstream reasoning simple and predictable. Let's move to rag.py. This file is responsible for retrieving relevant documents from Azure AI Search that were previously indexed from Azure Blob Storage. It forms the retrieval layer of our RAG pipeline. So let's start with the code. So first we have the imports and the setup, and each log entry is scoped into this module, which makes debugging and monitoring much easier when the application grows. So we define the function which takes a natural language query, retrieves the top matching documents from the search and returns a normalized list of results which is ready for downstream AI processing. The default top is equal to 3 limits responses to the most relevant content, helping reducing noise and token usage. Then we construct a search endpoint which uses the index that we created earlier and the latest API version. Then we build the authentication headers, which uses the search key that we extracted from the resource we built earlier. And then we construct the search body, which contains the user query. Top basically controls how many matching documents are returned. This uses a keyword and semantic search depending on the index configuration. Now we execute the search request and we use a http post request to submit the search query, and we have a timeout over here to avoid blocking the calls. Now non-successful responses are logged and the function fails safely by returning an empty data result set, and the Azure AI search returns matched documents inside the value field, and each entry represents one indexed document or chunk. Now, this is the most critical step over here because we are normalizing the results, and the Azure AI search schemas can vary depending how the documents were indexed. Now, this logic over here normalizes the field names, ensuring consistent output regardless of the index structure. Now, these are basically the fields that we defined in our index and indexer, and we have kept the same output keys to avoid breaking the collars. So we have mentioned some or options over here. So in cases where we, instead of the title, we use the name, ID or document in our index or indexer, the code should not get confused. Now, this function returns a clean and normalized structure that can be injected into our prompts and cited in the agentic responses. Lastly, we catch all the unexpected failures using an exception block over here. So let's save this file. Now let's move on to main.py. Main.py is the entry point of our solution. It wires together all the data capabilities and exposes them as MCP tools that an AI agent can call explicitly. At a high level, this file is supposed to do four things. It should initialize an MCP server using fast MCP. It should secure the access via authentication middleware, register the tools that combine multiple data sources, and run the server as a HTTP endpoint which is consumable by Copilot Studio. So we start off by creating an authentication middleware to enforce simple and explicit authentication. So this is the place where we have defined the authentication middleware. It requires a bearer token for all tool execution and validates the token against a locally configured key, which we mentioned in the .env file earlier. So this keeps the MCP server callable by agents but protected from unauthorized access. Then we create an MCP server named Cashflow Agent, which becomes the logical boundary for tools, resources, and governance. We have defined three tools over here. Get Cashflow Forecast is the primary orchestration tool which combines Fabric, the external API, and the Azure AI Search. This tool then builds a human readable answer, attaches clickable documents, which is basically our citations, and then optional monthly breakdown is also provided. The other tools are Search Document tool, which exposes Azure AI Search directly as a tool, and this is useful for standalone document retrieval and debugging or exploration. Get exchange rate wraps the FX API as a standalone capability. Then we have created an MCP source which defines a read-only resource backend by Fabric. The resources differ from tools in the way that they return raw data. They don't perform any orchestration as such, but they can be referenced independently by the agents. Finally, we expose the MCP server over HTTP and wrap with CORS middleware so Copilot Studio can call it cross origin and can be run locally or hosted in a container. Main.py is where data capabilities become agent callable intelligence. It exposes the governed tools that the AI can choose to invoke. So at this point, we have completed all the backend foundations and we have built an automated ingestion pipeline from SharePoint, a continuously updated Azure AI Search Index, secure access to live external APIs, and we have wired everything together in this main.py file through MCP. Now let's save the file. In the next episode, we will shift from foundations to deployment and integration. We'll create a YAML workflow that will deploy this MCP server to a Azure web app and expose it as a custom MCP endpoint. From there, we will connect this endpoint to a Copilot Studio and create an agent that can talk to these tools and securely invoke them. Thank you for watching and stay tuned for the next episode.